make 3 documentaries on the Shroud of Turin. On Friday, there was a group here videoed all day to make one in English. There was a group of 4 individuals came up from the Chinese church in Los Angeles, have been videoing for days now to make a video to be shown on television in mainland China to reach hundreds of millions in Mandarin. And for the last few hours, I've been videoing a documentary to be made in Arabic. And that's over in room 2. We are just finishing that up now with our 3rd camera. That's where our 3rd camera has been. So this is just amazing what's going on. Something like this, it starts to roll, doesn't it? Wow. Thurman's up here. We're going to ask Thurman to say a few words in just a minute, okay? Anyway, my objective here is to talk quickly why I don't believe that the cloth collapse theory is reasonable and the problems involved in the cloth collapse theory. Now, let's try and define what the cloth collapse theory is, as I understand it anyway. This says that the body disappeared from within the shroud in a very small fraction of a second. At least that's how it was initially conceived. And by, I believe it was John Jackson that conceived that, and then Mark Antonacci liked that, and so that there might have been some change, some gradual drifting apart between their 2 different views, but they were both basically cloth collapse scenarios. So that the body disappeared in a very small fraction of a second, and of course that would create an air pressure difference because what was the air that was left inside the cloth would only be that air which was between the body and the cloth. Whereas there was still full air pressure outside, so that when something like that happens, the body disappears in this very small fraction of a second, so that the cloth then starts to collapse, thus passing through what's called a radiant region, where it is exposed to radiation, so that the cloth collapse theory is actually a modification of a radiation theory. So it's based on radiation, it's just how it encounters that radiation that's the difference. And so that the cloth collapses through a radiant region in which it's exposed to radiation and thus is discolored by it. So that's basically, as I understand, the cloth collapse theory. Now, it occurs to me that there are several problems with this. And the first of which is that gravity, there's 2 forces involved here. Under the assumption that there's a disappearance of the body occurs in a very small fraction of a second. You do have a very significant pressure difference, and you have gravity. Now, the pressure difference would be acting on all sides of the cloth, maybe less so underneath, because underneath it's on probably the back bench in the tomb, so that as the bottom cloth would come up due to air pressure difference after the disappearance of the body, air would have to rush in to fill the gap and then to fill in underneath, so that there could be less of an acceleration of the bottom cloth up than the top cloth down due to air pressure difference. But gravity is only acting downward, and that has to be taken into account. So that the problem that this results in is that if the disappearance of the body is very rapid, then what happens is that due to the air pressure difference is much larger force than the force of gravity. So that the bottom cloth comes down, the top cloth will come down very quickly, the bottom cloth would come up, maybe less rapidly, but the problem here is that the sides would come in just as rapidly as the top would come down. So if the top comes down 6 centimeters, the sides would come in 6 centimeters. They'd go through the radiant zone. There would be, under this hypothesis, there would be images on the sides, which we don't see. So that's a contradiction. So to get around this, the last time we went down and talked with John Jackson, he said, oh, no. It's not a rapid disappearance of the body. The body disappeared over a day and a half to avoid this problem. Now the problem is just the reverse, and that is that the disappearance is so slow that there is no air pressure difference because the body disappears so slowly that there's, of course, air passes to a degree through the cloth, because the cloth isn't a perfect membrane, so that you essentially end up with no pressure difference at all. So then you only have gravity acting, and so you have no force to pull the bottom up into the radiant region. Now, any time span in between suffers from one or both of those problems. So there's no solution to that I can see. Next problem. Let's see if I can remember them all off the top of my head here. The next problem is that, let's see if we can think of this. Let me just talk here for a minute. One of the problems here is, the speed. The speed of radiation versus the speed of the cloth movement. Now, what's going to be the maximum speed of the cloth movement under air pressure difference? Well, a good bounding value for that would be the speed of sound, 1,100 feet per second. And what's the top speed of radiation? Oh, the speed of light, 186,000 miles per second. What's the difference between those two? It's a factor of 1 billion. Okay, that's a large difference. Now, what's the slowest that radiation would be expected to move? Well, if you had a particle released just at no additional energy, just in equilibrium with the surrounding temperature, called thermal energy, 2,200 meters per second, or about 720 feet per second, about 7 times the speed of sound. So that in either case, the radiation, as soon as the body disappears, the radiation would be gone. You really don't have a radiant region. The radiation is gone, and then the cloth starts to collapse. Now, to get into this a little bit, into a little bit more detail, just think of the forces involved between the presence of the body and when that cloth will start to collapse. Now, the cloth is not going to collapse while the body's there. The atom density of the body is so much higher than the atom density of the air and the pressure outside the cloth that you would have to have 99% of the body, if the body's disappearing gradually, that every cubic centimeter in the body is gradually disappearing over an extremely short or longer time span, then when does the cloth start to collapse? That is, that the force from the air outside the cloth exceeds the upward force from the body inside the cloth. Well, to a first estimate, it's when the atom densities are equal inside and outside. And when does that occur? It occurs when 99.5% of the body is gone, if it's a linear disappearance of the body. So in other words, if the radiation is being emitted as the body disappears, and the radiation being so much faster than the cloth collapse, then you have 99.5% of the radiation already occurs before the cloth starts to collapse. So that by the time the cloth starts to collapse, you've already had 99.5% of the radiation go through it, so that the remaining radiation that hits it after it starts to collapse is irrelevant. So therefore, that's why I said earlier, I believe the cloth will collapse, but it has nothing to do with the formation of the image, as I said. So that, you have questions. Let me bring Thurman up. This is your entertainment, okay? This is on his thermodynamic considerations related to the disappearance of the body. And this is my way to avoid